So in part 2 of the MST-80 video, we're going to take the system apart, ultimately so I can check power supplies, look at the board, etc. I don't have all of my chip removal tools, little organizer, any place I can find it. It's been moved. It's part of the shop reorg, and it's just at the moment missing. So I'm going to have to probably just use my chip lifter, which may be sufficient for this. The idea is to remove the more sensitive parts, which would be the 8228, the 8080, probably the 8224, the 31702s, and the 2112 RAMs. I'm guessing these parts have never been out of the sockets since the machine was manufactured over 40 years ago. I'm assuming it was manufactured, what we decide, 77, 78. So they may be really stiff. I guess we're going to find out. Let me find a pencil here if I have one handy. Again, everything is very inconvenient at the moment. Still trying to figure out how to organize stuff. See if I can find a mechanical pencil in here that works. I just want to write 1, 2, and 3 on these. I don't think these blue sockets are zero insertion force. Well, they don't appear to be. He's pretty easily shuffling up out of there, so like he came out far easier than I expected him to. That's kind of interesting. It's got a lead that's been soldered to it, looks like there, which is interesting. That was the number 2 chip. It looks like it could be some kind of zero insertion force. I'm going to have to look closer at them. For these EPROMs, I wouldn't be surprised if they were. Even maybe for the CPU. Wow, I'm really struggling to... I can almost guarantee you these aren't going to go back in the way they came out. Those are definitely zero insertion force sockets, so I need to figure out how to actuate them. But before I do that, since these are coming out fairly simply, I'm going to go ahead and remove them, just because I don't see a reason not to. Yeah, the pins, I can feel the pins squeezing back together. So how are these sockets actuated? Very interesting. Okay, I suspect the 8080 will come out the same way, and it did. It just popped right up out. There's a button there. That doesn't release it. Does we pull up? It does pull up quite a ways. I don't know. That's an interesting socket. I will have to look closer at those. The 8228 is an irregular socket. It is moving just fine. Remember, I am on a static dissipative surface here. The blue mat, and it is hooked up. You know, I've verified the ground. Its ground connection is actually going to the earth ground. Actually, it's been verified. It was verified shortly after I moved the desk around and hooked stuff back up. There's the clock and reset controller. There are 4 2112 RAMs here. I have looked at the data sheet for these and confirmed they are 1K bit organized as 256 by 4. So it takes 2 of these to get 256 bytes. As we finally surmised in the first video. Boy, when that popped out of there, boy, that looks like one of the early TI single swipe sockets, which are extremely unreliable in my opinion. Sockets that people covet for their Apple I reproduction boards, and just, in my opinion, garbage sockets. I am putting these into the foam in the order they're coming out. That is intentional. So I've captured all of these in the foam here, the three 1702s in the order they came out, the memory, and of course those three chips don't have an order, and they have a position, but there's not multiples of them. Do I want to pull out the displays? I don't see a reason not to, honestly, just to protect them. These are not made anymore. They are not super delicate, but they are delicate. That socket is actually up at an angle, like it shows there. So I will worry more about figuring those sockets out once this board has been removed. So maybe that's what we'll move on to next. Let me find an appropriate flat blade screwdriver. Let's see if these screws will pop loose. Yes. Yes. I believe everything else on the board is either resistor packs or TTL logic. It'd be a shame to lose that original logic, but it's pretty resilient. I'm not going to worry so much about static zapping it. I don't have a little organizer to drop these into at the moment. Crud. I'm just unprepared. I have not, of course, powered this system up yet. I just wasn't going to take a blind chance on there being a bad power rail and taking out, the vintage ICs. I'd much rather look at the power supply, or go through the power supply first, get a good visual inspection of the board. So I would expect this to lift up out. There's going to be a ribbon cable soldered on down here, which is this cable right here, and black does go to ground. These are soldered in the order they are in the cable. So I've got no problem unsoldering those. It looks, I don't know if there's a rework on the board or not. There's definitely flux. So let me fire up the soldering station. We've got a larger tip in it. Which tip do I have in the desoldering tool? That might actually work better for this. We'll find out. Still trying to figure out the optimum position of stuff in the new work surface. Board is silkscreen front and back, IC29. All the stuff looks to me in black. I don't think it's in the copper. No, it is in the copper on the back. I take that back. Here, so I think the desoldering tool at this point should be warmed up. We're going to add a little bit of fresh solder to these 4 tie points. Sounds like probably Amazon delivery going on outside. Not for me, but it does sound like there's an Amazon. I think that was an Amazon backup, what they sound like. Kind of a word sounding shh. So let's see if I can unsolder these cleanly. No. They are still obviously soldered on the back side, I believe. And of course they are. two of them have come out. Everybody but the ground. Oh no, there's the ground. So, and I know I didn't like lift copper or anything doing that. So nice. Let me clean this up. I don't see any other solder on the back side. They look fine on the front, so that removes the board. That's very nice. We can set it over here out of the way. And we've got this huge blue electrolytic here that is used in silicon to hold it in place. So this might be an interesting supply to rebuild if I have to. I don't know if I can get it to spin without the screw spinning below it. Well, in this case I can. The ones back there are going to be a lot more interesting to try to deal with. Oops. This one actually came loose easy as well. So I'm going to have to lift here, which means your view is going to be not nearly as good. I think I'm going to have to set it up on its side and try to break this loose. Oh, and those are Phillips. Lucky me. Okay, that one came loose. And this one looks to be the rubber foot as well. And I suspect it's a flat, because these rubber feet are always a flat. So, and it is. Nope, I'm going to have to keep turning it with the screwdriver. That is being a goober. I haven't completely removed that top one. That was to hold the supply in place. While I removed this one so that its weight wouldn't try to move things around. I can see what they did now. The silicone in the first video that we saw on these nuts, I think, was to hold them in place while the screws were started. So, can I get you to back the rest of the way out, or do I need to spin you back in? I think I'm going to spin you back in, just so the briefcase will sit flush. And I may be able to spin this nut off by hand, and I can. Here is that nut. Let's go ahead now and sit this back upright. Hopefully it's in view here. And this should now lift out. It does. Oh, it is an old school switching supply, I think. No, CP111 Power Systems. It's got a couple of ICs on it. I do suspect it's a switching supply. There's an interesting find. It's an old school, and I mean old school, crystal earpiece. That's actually pretty cool to just randomly find trapped in there. This power supply is very much of the era, and actually not this one particularly, but the ones made like this are very familiar. My 8-inch floppy drives used a very similar supply to this, you know, on the metal backing with the transformer up front. This isn't switching. I don't know why I'm sitting here saying it is. I don't think it's switching. There are voltage adjustment pots. There are film capacitors. There's a really lousy job right there, in my opinion, of a solder connection. I guess it looks like it's solid. I'll probably redo that and use some shrink tubing on there just to clean that up. This is interesting. The chassis ground isn't grounded. I would have personally connected it to the metal plate here. That just would have been my personal connection point. Green, black, white, green. Oh, it is minus 12. It says minus 5 or minus 12 there. Okay. 8,000 microfarad, 15 volt. I see no evidence that that capacitor has failed. I see no evidence that this one has failed. I don't see any resistors that look like they've cooked. There's another crazy joint like that, a butt joint. That's just how they did things. I don't see any evidence of doming, and I don't see anything that's leaked out. I think underneath that cap, boy, is the kludginess of this just kludgy. There is 1, 2. I don't know if you can see the footprints. There is a footprint here for a, what is that package? Q4 for a large pass transistor or a large transistor, and there's a second one over here. And I'm suspecting that in the end is the plus 5, or in this case the plus 12. Plus 5 is sitting here. There's a third one down here. You can kind of see the outline. So this is probably the minus 5, the plus 5, and the plus 12. Ultimately, the regulator is going to be some kind of a transistor, 2N3055, something like that. I suspect these are probably, I get a look at the ICs, 723, 724, it's been a long time. 723 and a 723. So these 723s, these dips, are voltage regulators. So they are a voltage regulator that controls a pass transistor to generate a voltage. I cannot talk here. A regulated voltage rail. Man, I can't talk this morning. So there are two 723s in here. There's an SCR up here, SCR. So there may be an over voltage crowbar someplace on this that would trip the SCR. Would potentially short the supply. There's a fuse up here and hopefully blow that fuse. I'm looking at the diodes. There's a little bit of, I think that's just molding. There's been heat on these two. And there's really been heat on a number of these. The marking bands have started to fade, but there's what's probably a full bridge rectifier there, probably a full bridge rectifier here. Half wave rectifier for the plus 5. I don't believe it would be a half wave, but they are large, chunky diodes. These two black leads. So there's two black leads that come in here directly to two diodes, which makes me think there's a half wave bridge here. Or it's center tapped. Oh, it's center tapped most likely. So the white's going to be the center tap. So that's going to be the taps, I believe, for the plus 5 rail. Center tapped. So that makes sense. It's a single diode. So you're 50% of the load on one side of the transformer, 50% of the load on the other. And then there's going to be probably, this looks like it comes around to the minus 12 volt and the plus 12. So as I familiarize myself with this, it's making more and more sense. This is going to be the adjustment for the minus 5, for the plus 12, and for the plus 5. It looks like all three of them are independently adjustable. I may be able to find a schematic for the CP111 power systems power supply someplace. I may not. There's going to be a label probably on the side we can't see with the ratings. I'm at this point not going to pull the supply out. It's kind of a pain dealing with how these are mounted. But this metal is definitely a heat sink, and these large transistors or on the back side of the board, you know, the back side of this aluminum bracket, and then it's using the aluminum bracket as the heat sink. So this makes a lot more sense to me. In the first video, I kind of felt around trying to feel for screw heads over here, wondering if there was like a 7805, 7812, 7912, and there wasn't, but there was these cooling holes. It's interesting that the line cord just pops through. There's no real strain relief on it. These screws, of course, are holding the proto board in place. Power supply switch, which is mounted pretty crude, but it's mounted. There's nothing here that's surprising for the era. Safety-wise, you could accidentally end up with it'd be difficult to do, but with 120 volts live on this metal plate. This really, in my opinion, should have a ground lug on it and be tied to, you know, preferably one of these connections here. I will probably make that modification just for safety. But I think in this case, 8,000 microfarad, 15 volt. Do I want to put a variac on this and give the capacitors, the big one here, a chance to reform? I don't like it's a huge computer grade electrolytic. I really would prefer not to try to remove the leads here to test it out of circuit. 8,000 microfarads is going to take a long time to charge. I don't think any of my capacitor testers will test it. I'm in my brain jumping back and forth here. Do I want to go grab the variac and bring this thing up slow? And I think I'm going to do that. So, well, I need to make a better base for it. It should be set up on something, and it's not at this point. But that is what it is. We're going to take the line cord. You can see I've kludged in. I've taken a heavy-duty line cord here, and I've kludged it in. Let's crank this around to the 0 volt precision. This had a rough life at some point. I think that's kind of obvious. Let me plug this in. The switch looks like it's already in the on position. It isn't actually labeled on or off. I don't know. When I come to DC volts, I am knocking stuff on the floor, as I always am. So the black lead comes to here. I think I can just clip on. Actually, I probably can just clip on down here to get a ground. I don't expect this to jump straight into regulation because I won't have enough incoming voltage, but I should be able to see some of the voltages in the system. That gets the meter to a common ground. Now let's go to volts AC. Wherever the heck. Okay, is it both AC, DC? Yeah, DC. Let me switch it over to AC. Let's take a look across the transformer if we can clip on. Quit spinning. Please get a grip on there. Power strip on. Okay, because the position of the switch to me says it's off. I need to toggle that way to bring the switch on. And we can see AC voltage starting to come into the system. So I'm going to shut down now, and I'm going to go back to the DC side. And I guess for DC I can really just clip on right there. If I can get my finger on the... So that is a ground point. Let me get back to DC mode. AC is on. I don't know why there's that residual 0.45. There we go. Okay, we're starting to see voltage across this cap. I'm going to leave it at, so we've got 0.9 volts across this cap. And we've got 2 volts across this 500 microfarad. This is the one I'm more worried about. I'm just going to let that sit here for a while. Give this capacitor a little bit of time if it needs to reform. I know a lot of people say they don't reform. They do reform, never reform them, they're less reliable, whatever. I'm going to let this sit for a while at the 1 point something volts. Well, at the 0.9 volts, which is starting a little higher, honestly, than it probably should, but it's not discharging, that's why that's not coming down. So there's nothing to discharge at this point, nothing's coming active to discharge it. It'll roll off on its own. Well, it is holding a charge. You can see it slowly, hopefully you can see the meter slowly rolling off there. So I will quit yapping here. I think we're going to call this video up to this point finished. This is plenty of length for a video, and we will pick this up in the next video. I hope to see you there. If you liked the video, please give me a like. If you didn't, tell me why in the comments. If you think the channel's worth subscribing to, give me a subscription. I'm really not driven by likes and subscriptions personally, but they're nice to have. It's nice to see the numbers growing, just so I know people are actually finding the channel. Hopefully you found something here you enjoyed, and we'll talk soon.